Okay, so just to go through the lessons that I've posted for you regarding stretching, reflecting, and translating, just to briefly talk about some of the items here. So again, the concepts were discussed in the Desmos files that I'm going to add links in the description for this video when I upload it. But again, the main concept for this idea of stretching and reflecting is always to compare it. So you have a parent graph that you're familiar with. And when you make a comparison to the algebra and then plot the points, you'll see things happen. So you'll notice the a value in each one of these algebraic expressions for a quadratic are different. You have a +2, a -3, and a 0.5. So each of these will produce different comparative graphs. So that's what we're going to take a look at. So the comparison here, let me just get rid of this little blob here. All right. So the comparative graph for y equals x squared, I've got them labeled here. So there's y is equal to x squared. Now when the a value becomes 2, we refer to that as a vertical stretch by a factor of 2. So again, comparing the blue, which is your parent graph, to the x squared, 2x squared. The 2x squared graph here, in comparison to the blue one, has been vertically stretched. So again, that comes from taking a look at the y values, and they've been stretched vertically. And that's because the a value for the new expression is larger than 1. Whereas if you look at the red graph, in comparison, so the values here have been changed by going in a downward direction compared to the blue. So in comparison to the blue, the red graph has been pushed downward, compressed vertically. If you look at the a value is 0.5, it can also be written as a fraction. Okay, so those are the main concepts you need to kind of concern yourself with in terms of dealing with what's going to happen for stretches and compressions. All right. So you add in the reflective property because the a value is negative. So not only is this been pushed away from the x-axis in comparison to the blue, so the blue graph, if it was just reflected, would kind of look like this. But as you can see, the green one has been pulled farther away from the x-axis or stretched vertically, but it's also been reflected. That's because it's opening down. Okay, so you got to get used to the algebraic notation, which isn't too bad. So again, the notes down here are just simply giving some finer details. So what's happening with the graph, if it's becoming thinner, then we say that's being stretched vertically. And if it's stretched thinner and pointing in the opposite direction, in other words, downward, then it's not only is it stretched, but it's also reflected. All right, so that's where this language is coming from. So again, there's the a value. So the a value is greater than 1, then we know it's a stretch. If the a value is between 0 and 1, we know it's compressed. And if the a value is negative, regardless of whether it's bigger than 1 or not, we know there's a reflection that has taken place. Okay. So these are just some practice questions for you to take a look at. So here what's happened is you have a parent value ordered pair 2, 4. Okay. And what you're asked to do is, if the graph is transformed, determine the coordinates of the transformed point. So if the a value is 4, then the equation will be a y equals 4x squared. Remember, this only affects the y value. So the transformation as described in the Desmos video, which again, I'm going to provide the links in the description. So it's only the y value that gets affected. Okay, this is just a vertical stretch by a factor of 4. So it's just the y value that gets affected. How does it get affected? Through a multiplication of 4. So in part B here, again, you're given the parent point. A value is negative 0.5. So again, there's the equation. So it's only a stretch and a reflection. So the y coordinate for the key point, not only should it change signs from positive to negative, but it should also be closer to the x-axis, which it is. Okay, so 4 is farther away from the x-axis than 2. So that's the way you got to look at it. So this has been compressed. So there's the new point. And again, there's a multiplication going on there. So why is it a multiplication? Because you're taking the original y value and multiplying it by that a value. Exactly like what was done here way at the top in the table. So all of these y values from the original table were multiplied by the a, multiplied by the a, multiplied by the a. And similarly, I described that in the Desmos video that all, again, is in the link in the description. Third one here. So you got 2 points or two values, x and y, for on the parent graph. The a value is 2/3. So there's your equation, 2/3 x. So again, it's a stretch or a compression by 2/3. How do I know it's a compression? Because 2/3 is less than 1. It's between 0 and 1, so we say that's vertically compressed. So the ordered pair should have the same x value, but the y value should be closer to the x-axis. So it should be less than 9, which it is. It's 6. And why does that happen? Because it's the 9 multiplied by 2/3. So it's take the original y value and multiply it by 2/3. So these new points that you see here, these are for the transformed graphs. Okay, so that's what you have to realize, is that they're all for the transformed graphs. If you were to graph them, that's where they would appear. The easier part is supposed to be translating in words. So if you're given the original graph, y equals x squared, and you have a new equation, y equals 6x squared. 6 is an a value greater than 1. So again, if we go back to this little notation, if it's greater than 1, then we must use the language vertically stretched. So the graph, the parent graph, is being vertically stretched by a factor of 6. Now again, that language was used in the Desmos video. Down here, you have the a value is negative 1/5. So 1/5 is less than 1, but we also have a negative. So there's two things going on here. So the parent graph is being vertically compressed by a factor of 1/5. And vertically reflected, shouldn't be down on that line, so I apologize for that. Can also be phrased reflected in the x-axis. Okay, so again, that comes from this language up here, vertically reflected. So there's two things going on because of the negative and the 1/5. All right. The hardest part is determining the equations when you're just given a graph. So you're given the graph of the parent y equals x squared. All right. What you're trying to do is try and find the a value. So if you pick a point that is on the new graph that you're given, it doesn't really matter which one, but as long as you can accurately pick out the point, and you take a look at what's happening here. So you've done this type of work before where you've replaced variables with numbers, right? So the point that you choose on the new graph becomes the x and the y in the generic equation that you're going to use. So what I mean by generic is that you don't know the a value, all right? So you don't know what this a value is, you're trying to figure it out. So you pick a point, x and y, on the graph that you're given and calculate the a. You have done similar work like that before. So here the a value becomes 1.5, 1 squared is just 1. So that gives us 1a equals negative 1.5. So therefore your equation is negative 1.5 x squared. Okay. So what you can do in Desmos, if you'd like, you can graph y equals x squared, and you can graph y equals negative 1.5 x squared, and you'll get exactly this same picture. For the translations up and down, this is a lot more straightforward, so I'm going to go through this relatively quickly. So this notation is a little different. Okay, this will be referred to as vertex forms. Okay, so as in the Desmos video that I'm going to provide the link with, as you can see, I've got the little item here. This will talk about the H and K being key letters to denote your vertex. All right, so the K value as I showed you in the Desmos video, makes your parent graph move either up or down depending on if the k-value is positive or negative. So that's what's being talked about here, and a little summary there. And then with the h value, if the h value is positive, now notice the format, it's x minus whatever that h value is. So if h is 1, then it's x minus 1. So the h value is positive, move to the right. X minus 3, your h value is 3. Again, h value is positive, move to the right. The reason why the algebra here changes is if the the h value happens to be a negative. Okay, so -2. You keep this part of the algebra. This stays the same. Okay, you do not change that. So it's x minus whatever that h value is. When you subtract a negative, that becomes a positive. Okay, so that's important to note, especially when you're dealing with the algebra. And that's why you get these a values or the h values here looking like they're not really there, but that's what this is, just cleaning up or simplifying of the algebra. So here your h value is actually negative, your graph will move to the left. Here your h value is negative, again, your graph moves to the left. So if your h value is positive, your parent graph will move to the right. If it's negative, your parent graph moves to the left, right? And then as I showed you in the video, you can do a combination of moves. So if you're given the h value and the k value, then you can come up with your equations. So again, notice that when the h value is negative, the algebra has this look to it. So the x take away -3, which is x plus 3. And then adding the k value, adding a negative, gives you -5. So this is a simplified version of the algebra. So if your h value is negative, that means the graph has moved to the left. If the k value is negative, the graph has moved down. So it's moved 2 different directions, to the left and down. Okay, so again, what might be helpful is if you have the Desmos file or some sort of graphing software, graph both. Graph y equals x squared and then graph this new equation, and you'll see how comparing the parent to the new graph, how this translation has taken place. So similarly, when the h value is positive, the algebra is x minus 4 all squared, and then the k value is 1, and you have that plus 1. So the graph has moved 4 to the right and 1 up. So it's very important that you know how to look at the algebra and interpret the movements of the graph, or the stretches and compressions, and that'll help you in the long run. So again, this down here is just taking some of that information. So if you're trying to come up with the equation, the graph is shifted 2 units to the right. That's an h effect. So the h value is 2 to the right, so h is positive. So notice the algebra, x minus 2 all squared. Shifted 3 units to the left, so your h value is negative. So again, x minus -3 becomes x plus 3 all squared. You need the squared in there because these are quadratics. Shifted 4 units up, k value now. So for up and right, up and down, that's k value. So the k value is 4. So there's no h value that you can imply, so it's just x squared plus 4. Here it's a combination, 5 right and 3 down. So you have the h is 5 for the moving to the right, k is 3 negative because it's moving down, and there's your corresponding algebra. All right, so it's important to get used to the language as well as the corresponding algebra. And then here in this last example is just trying to create a graph by using the language and coming up with new ordered pairs. So here's the parent values, which you do need to know. The only transformation that's happening is, notice the h value here is 2. There is no k value. You don't see anything after the square. So it's an h value of 2, which means the graph is shifted to the right. If the graph is shifted to the right, now take a look at this. So the black is the parent graph. So the only thing that's happening is these points here are all moving to the right. So you take them all and move them to the right. Okay? So that's where the only coordinates that are being affected are the x coordinates. So if you notice, it's only the x coordinates here that have changed. The y coordinates are exactly the same as in this column. No difference whatsoever. All right, and so how does that happen? You just add 2. Okay, 2 to the right add 2, and you'll get a new set of ordered pairs, and you'll be able to come up with a graph. And similarly, if you're doing a combination, so here the h value is negative. How do you know? Well, look at the algebra. So it's x plus 4. So the standard algebra, or the generic one, is x minus h. So the only way this is going to become a plus is if the h value is negative. The k value always comes on the end, so that's k is negative 5. So there's 2 things that are happening. The graph has moved to the left 4 because of the h, and down 5 because of the k. So to move left 4, that's your x coordinates that are changing. You subtract 4 from all these parent x values. Down 5, all the y coordinates have to change by subtracting 5. You get your new points, plot them all, and you got your new graph. Okay, so hopefully this clarifies some of the issues that are going on in the lesson. So I will add the links in the description of this video to the Desmos files to make it easier to find them.